Good afternoon, students. In this video, I will explain about the transmission. So, transmission. What is transmission first? Transmission is a mechanism which transmits power from engine to the road wheels. Already you know the power will be generated in the vehicle engine of the vehicle engine. So that power should be transmitted to the road vehicles. That can be done by using this system. We are having different systems. Those are known as what it is. Those are the transmission systems. From here onwards, transmission is used in the sense that a mechanism which provides suitable variations of the engine torque at the road wheels. This may be a gearbox or a manual transmission or an automatic transmission. Now, the types of transmission system. What are the different types of transmission system? The automobile transmission system can be mainly classified into two types. Those are manual and automatic transmission system. Manual and automatic transmission system. In case of manual transmission system, the vehicle is driven with the assistance of gear shaft and foot clutch. The other components which are used in these processes are flywheel, pressure plate and ring gear. So these are the different components of the manual transmission system. In detail we will discuss uh, later. And in case of the automatic transmission system, the gears are changed automatically corresponding with the vehicle speed. As per the vehicle speed, the gears will be changed automatically. For that we need different components which are there in the automatic transmission system. Those are modular, torque converter, planetary gears, governor, computer is also required here, seals and hydraulic designs. Okay, so these are required where in the automatic transmission system. Now I will explain about manual transmission system here in detail. So all transmission system has a reverted gear train which consists of an input and output shafts, or input and output shaft. Input shaft here is the clutch shaft and output shaft here is the main shaft, whose axes are in the same line. Those axes are in the same line. A lathe shaft or a counter shaft, we can say that a lathe shaft or a counter shaft is located directly below these shaft. From the clutch disc, engine power goes into the transmission through the input shaft, that is clutch shaft. In direct drive, the clutch shaft is coupled to the main shaft so that power transmission takes place directly between them. In reduction, power goes lay shaft and then reverse back to the main shaft. So like you are having here. And now again, the manual transmission. Sliding mesh gearbox consists constant mesh gearbox, synchro mesh gearbox 3, 4 and 5 speed. In sliding mesh type, all the gears on the lay shaft are fixed all the time. They are rotating when the engine is running and clutch is engaged. The gears on the main shaft are free to slide on the splines. Different gear ratios can be obtained by moving the main shaft gear to the left or right by means of selector mechanism. This gearbox gives 3 direct and 1 reverse speed. In constant mesh type, all the gears on the main shaft and lay shaft are in constant mesh with each other. Okay, all the gears are meshed with each other here in the constant mesh type. The lay shaft gear are fixed. Okay, lay shaft gears, whatever we are having here in the system, those are fixed to it. And usual and main shaft gears are free on the splines of the main shaft. The two dog clutches are moved either to the left or right to get different gear ratios. Here dog clutches are used which will be moved either left or right to get different gear ratios as per our requirement of gear ratios. Here dog clutch will be move left and right. Now synchro mesh gearbox you are having here. The gearbox is similar to the constant mesh type, that is, all the gears on the main shaft and lay shaft are in constant mesh with each other. The gears on the main shaft are free to rotate, and gears on the lay shaft are fixed to it. It is obvious that for one gear to the mesh with another quietly and without damage, they must have to rotate at nearly the same speed. In constant mesh type, the dog clutches to engage smoothly. The speed of the main shaft gear and dog which is sliding must be equal. Therefore, for obtaining lower gear speed of the clutch shaft, lay shaft, and main shaft gear must be increased, and is accomplished by the double declutching. The double declutching procedure is as follows: the disengage the clutch and brought the gear to the neutral position. Engage the clutch and increase the speed of the main shaft gear by operating accelerator pedal. Disengage the clutch and put the required lower gear. Engage the clutch. As the clutch is disengaged twice, this process is called double declutching. Means what it is, clutch, if at all it is de-engaged twice, this process is called as double declutching. For obtaining higher gear, we have to go in the reverse manner. For smooth engagement of title gear, we have to wait with the neutral gear till the main shaft speed is decreased sufficiently. But most of the transmissions are equipped with the synchronizer or avoid the process of double declutching. The member to the engaged are first brought into the frictional constant. This makes their speed equal, and the members may be engaged smoothly. However, these devices are not fitted to all the gears. They are used only in the higher gears. Dog clutches are used on low and reverse gear to reduce the cost. Okay. Now the typical diagram of synchronizer is shown in this figure. So here you have figure, I given already notes, so there you can observe clearly those figures. Now here this figure is not clearly visible, so better refer my notes. There you have clear diagrams. Okay, so just I will explain this. Okay, now figure you are having here, I will explain this. The sliding hub C, capital C you are having here, capital C. This is the sliding hub. Okay, C, sliding hub is free to slide on the spline of the main shaft. A ring member D having internal teeth fit on the external teeth of sliding hub C. H is the dog clutch. Here you are having H is the dog clutch. You may observe here. Here you are having H is the dog clutch. Okay, H is the dog clutch. Dog H is the dog teeth on the clutch. Okay, on the dog teeth on the clutch gear. B and also fit on the teeth of the D. Okay, E is the fork fitted on the D. G is the ball supported by spring and prevents sliding of D. On C, when axial force is applied on the D through E exceeds certain value, the balls are overcome and D slide over C. F1 and F2 are the friction surfaces. So whatever A, B, C, D you are having here, H is, you are having H, G, and F means what it is, frictional surfaces. Those are all which are shown on in this particular diagram. You refer to that this diagram to obtain gear. Now next, to obtain gear ring member D and hence sliding hub C is slide towards left till friction surfaces F1 and F2 rub each other and friction makes their speed equal and further pushing of D towards left causes the ring member to override the balls and get engaged with the dog H and provides direct drive from gear E via C and the splines. Similarly, second gear is obtained by sliding hub C to the right. So likewise, the clutch's transmission system will be work. Now 3 speed synchro mesh transmission. In this type, all the gears on the main shaft are in constant mesh with the corresponding gears on the counter shaft. The main shaft gears are free to rotate while counter shaft gears are fixed to it. Since all the gears are constant mesh, the gears on the input, that is clutch shaft, and main shaft, that is output shaft, and counter shaft are uh, varies rotating with the running condition of the engine. That is, when the clutch gear is rotating. The figure shows fully synchronized transmission with a forward speed having synchronizing devices. The different gear ratios are obtained as follows. We are having here one by one. Now, low gear or first gear. Low gear is obtained by moving synchronizer 8 to the left and synchronizer A is still in the neutral position. A friction surfaces A friction surface rubs against each other and the friction makes their speed equal. Further pushing synchronizer 8 causes it to mesh with teeth low gear number 4 and the drive is transmitted through 1, 2, 12, 10, 4, 8 and 6 input shaft gear 2, 12, 1, 4, 2, 12, 10, 4 synchronizer 8 through the splines to the output shaft and low gear is obtained. So likewise you will get the low gear. Okay, how the process will be taken place during the first gear. So this is what it is you are having here. Now the second gear, when the synchronizer A is slide to the right, it meshes with the gear 3 and second gear is obtained. The drive is transmitted through 1, 2, 12, 9, 3, A and 6. Okay, you are having those numbers here 1. Okay, so as per this number you just observe the diagram and similarly the process will be taken place during the second gear, that is. Okay, now the third gear. This is known as third or a high gear direct high gear okay, high gear or third gear. This is also known as direct gear. When synchronizer A slides towards left with the 8 is in neutral, it matches with the teeth of the gear 2 This locks the input and output shaft together, and the power flow is direct. That's why it is known as direct gear. The clutch cluster is driven and still turns the second gear, which is free to turn on the output shaft. Okay. Now next one is reverse gear. After third gear, and now reverse gear. Reverse gear is obtained by moving synchronizer 8 to the right and A in the neutral position. The input shaft turns, the cluster, which is turns, drives the gear 5 through uh, 2 and 8. Okay, the idler gear 8 changes the direction of the rotation of input shaft 1, 2, 12, 1, 12, 11, 8, 5 and 6. Okay, as per whatever you are having those number on this diagram, you refer that one, so you come to understand how the reverse gear will be taken place. Now synchro mesh gearbox or 4 speed. We are having this diagram here. Figure shows 4 um, forward and 1 reverse speed transmission. It contains additional gearing to provide for fourth speed. All forward gears are synchronized. Gear teeth are helical cut with the exception of the reverse sliding gear. So whatever the gear you are having here which are helical cut, except that reverse sliding gear and rear reverse idler. The figure A and E shows gear drive position for the various speed. Figure A to E, you are having 5 diagrams here, 5 diagrams, so those will be shows totally 5 various speed drive position of the various speed 1 2 3 1 2 3 4 5 A B C D E. Okay, now overdrive one by one we'll discuss overdrive and then clutch or freewheeling mechanism. So these two will discuss today, and in the next video we'll discuss about the planetary gear system. Okay, now overdrive. When the standard transmission has been shifted into high gear, the ratio between the clutch shaft and mechanism main shaft is 1:1. So whatever the ratio we are having here, what it is, transmission has been shifted to high gear. The ratio between the clutch shaft and transmission main shaft, the transmission main shaft, that ratio is 1:1. The unit overdrive is located on the back of the transmission between the transmission and propeller shaft, provides speed ratio over that of direct or high speed ratio. The overdrive allows the engine to operate at only about 70% of the propeller shaft speed when the vehicle is running at the higher speed. Overdrive mechanism, the special equipment causes the main shaft to the overdrive or a turn more rapidly than the clutch shaft. When the overdrive is put into operation, it drops or it decreases the engine speed by about 30% without changing vehicle speed. Suppose if the vehicle runs 40 km per hour or kmph in direct gear with an engine rpm of 2000 rpm, the use of overdrive would decrease the engine speed to 1400 rpm without changing the vehicle speed. it maintains 40 kilometer per hour, 40 kilometer per hour only. When 40 kilometer per hour vehicle speed. Essentially, the overdrive consists of a planetary gear system and the freewheeling mechanism. Freewheeling mechanism. Overdrive. Overdrive is the highest gear in the transmission. Overdrive allows the engine to operate at a lower RPM for the given road speed. This allows the vehicle to achieve better fuel efficiency and often quieter operation on the highways. When it is switched on, an automatic transmission can shift into overdrive mode after a certain speed is reached, for example 70 plus kilometer per hour depending on the load. When it is off, the automatic transmission shifting is limited to the lower gear. For automatic transmission, it is almost always best to select overdrive and allow the transmission to control engagement of the overdrive. It may be necessary to switch it off if the vehicle is being operated in a mountainous areas. Mountainous area means hilly areas, okay, carrying a heavy load, or when the driver is wishes to intentionally keep the engine running at a higher speed RPM for quicker acceleration. With a manual transmission, overdrive should usually be selected when the average speed is about 70 km per hour. The automatic transmission automatically shift from OD to direct drive when more load is present. When less more load is present, it shifts back to OD under certain conditions. For example, driving up hills or towing a trailer, the transmission may be hunt between OD and the next highest gear shifting block and forth. In this case, switching it off can be help the transmission to decide. It may also advantages to switch it off if engine braking is desired. For example, when driving the downhill, the vehicle owner manual will the vehicle owners will manual will often contain information and suitable procedure regarding such situations for each given vehicle. Now roller clutch or freewheeling mechanism. Roller clutch or a freewheeling mechanism, the special form of a ratchet is the word overrunning clutch. Have you ever thought about that kind of mechanism drives the rear axle of bicycle? It is a free wheel mechanism which is an overrunning clutch. Figure 8-2 illustrates simplified model. Okay. Freewheeling mechanism you are having here simplified. You are having this diagram. So this is the diagram for the freewheeling mechanism. Freewheeling mechanism. As the driver develops torque to the driven member, the roller or balls are wedged into tapered recesses. This is what cue the positive drive. Should the driven member attempt to the drive the driver in the direction shown, the roller or balls become free and no torque is transmitted. No torque is transmitted. Now, the mechanical or automatic engineering. In mechanical or automatic engineering, a flywheel or overrunning clutch is a device in a transmission that disengages a drive shaft from the driven shaft. When the driven shaft rotates faster than the drive shaft, an overdrive is sometimes mistakenly called flywheel but is otherwise unrelated. The condition of a driven shaft planning faster than its drive shaft exists in the most bicycle. When the rider holds his or her feet still, no longer pushing the speed pedals. In a fixed gear bicycle without free wheel, the rear wheel would drive the pedal around. The simplest flywheel device consists of two saw tooth spring-loaded discs pressing against each other with the tooth sides together, somewhat like a ratchet, whatever ratchet mechanism we earlier discussed. So same mechanism here you can use here. Same mechanism is used here, rotating in one direction. The saw teeth of the drive disc lock with the teeth of the driven disc, making it rotate at a same speed. If the drive disc slows down or stops rotating, the teeth of the driven disc slips over a drive disc teeth and continue rotating, producing a characteristic clicking sound proportionate to the speed difference of the driven gear relative to that of driving gear. More sophisticated and rugged design has spring-loaded steel roller inside a driven cylinder, rotating in one direction. The roller lock with the cylinder, making it rotate in slower, or in the other direction. The steel roller just slip inside the cylinder. A flywheel mechanism acts as an automatic clutch, making it possible to change gears in the manual gearbox either up or down shifting without depressing the clutch pedal, limiting the use of the manual clutch to starting from standstill or stopping. The SAAB means Saab free wheel can be engaged or disengaged by driver by respectively pushing or pulling a lever. This will lock or unlock the main shaft with a free wheel hub. A free wheel also produces slightly better fuel economy or carburetor engines and less wear on manual clutch, but leads to more wear on the brakes as there is no longer any ability to perform engine braking. This may make free-wheel transmission dangerous for use on the trucks and automobiles driven in mountainous region, as prolonged and continuous application of brakes to limit vehicle speed soon leads to brake system overheating, followed shortly by total failure. So likewise here transmission process will be taken place. We are having here this diagram, overrunning clutch with a roller in engaged position, solid drive or a coupling. So this is what we are having the diagram, and in the next video we discuss about next part of the syllabus, that is planetary gear system or a epicyclic gear trains. Okay, that we'll discuss in the next video. Thank you for watching this video.